Section 2.3 is on Venn diagrams and set operations. So just like in algebra, there were four main operations: addition, subtraction, multiplication, and division. Sets also have operations, but their operations are a little bit different than the ones we would see in an algebra course. Before we get into those operations though, a universal set, which is symbolized by a capital U, is a set that contains all the elements being considered in a problem. So there are a couple different ways that they can present you with the universal set. If it's a Venn diagram, you're going to see a U in the upper left-hand corner of that box, of that Venn diagram, and that's their way of saying, hey, every element you see in this box is a potential answer. It's part of that universal set. You'll also see later in this video when it says U equals, that's their way of labeling the universal set. Here are all the possible answers you could have by the end of this question, is really what they're saying. So looking at example 1, we're going to use the Venn diagram to determine each of the following sets. So we are going to list all the elements in the following sets. Please be aware, by the way, if you see Roman numerals in these Venn diagrams, these Roman numerals are labels for certain regions in the diagram. The Roman numerals are not elements. So when they're asking you to type elements, please ignore the Roman numerals. So I'm going to put a slash through them. Since they want elements, we're going to ignore the Roman numerals for this question. So the actual elements are little a, b, c, d, e, f, g. All right, so starting with question A, what is set A? They want us to determine set A. So visually, that of course is everything inside circle A, right here. So what is inside circle A? Well, it's a set. We're still talking sets, so yes, we do unfortunately need to keep drawing those curvy brackets. And inside circle A, in any order, I see a little A, I see a little B, I see a little C, and I also see little d. Close the brackets. Don't hit spacebar. You would just type it in just like that using the keyboard to get in those curvy brackets and the commas. And that's the final answer for set A, or circle A. Now looking at B. So part B says the set of elements that are in B but not A. So I don't want A, it says but not A, so let's get rid of A. So now what's left in circle B? Now that I got rid of A, well, the only thing left in circle B is that little E. So put the little E inside those set brackets. And that's the final answer, the set of E. All right, now looking at question C, the set of elements in the universal set, that's what that capital U means, that are not in A. So again, we don't want A, so I'm going to X out A. So everything left in the universal box. Well, we still have little E that's not in circle A. And then we got little F and G are not in circle A, but still in the universal box as well. So that's my final answer, E, F, G. Notice the elements, when the elements are letters, they need to be lowercase because capital letters denote the sets themselves. So little letters are elements. Looking at D. Now D says the set of elements that are in the universal set that are not in A or B. So I don't want A or B. So the only thing left in the universal box, if I get rid of the circles, are little f and little g. Remember, we just want to list the elements, ignore the Roman numerals. The Roman numerals are labels, not elements. And then finally, I didn't have enough room to put it on the bottom, so I put it over here. They want you to type in the universal set. So that's all the elements that are in the box in any order. So that's A through G. A, B, C, D, E, F, G is the universal set. Those are all the possible answers that you could have. Final answer. The complement of set A, which is symbolized by an apostrophe. So when you see that apostrophe attached to any set, that is going to be read out loud as complement. So I'd read this out loud as A complement. So the complement of set A, symbolized by A complement, A apostrophe, is the set of all elements in the universal set that are not in A. So it's not as bad as it sounds. I know this definition makes it sound a little bit harder. This idea can be expressed in set builder notation as follows. So we see that it is in the universal set, however, it's not in the set itself. So my memory trick, whenever I see that apostrophe, I'll put apostrophe equals. It means what's not in that set that it's attached to, because it doesn't have to only be attached to A, like in the definition here. So it's not in the set that the apostrophe is attached to, but still in the universal set. Because remember, the universal set are all the possible answers you can have by the end of the question, but still in the universal set. And you might want to even jot that down, especially when you're preparing for the test on this chapter. Some sort of memory trick for each of these set operations can definitely help. Another memory trick I've heard for this one is it's the opposite of that set. So what are the opposite elements? So looking at example 2, once we see it in action, we see that it's a little bit easier than it sounds. So looking at example 2, it says to find each of the following sets. U equals, remember, whenever it says U equals, that means universal set. In other words, all the possible answers we can have by the end of this question. So the universal set, or all the possible answers, are the numbers 1 through 7. They give us also 2 subsets of the universal set. They have subset A, which is the set with 1, 3, 5, 7 in it, and subset B, which is the set with 1, 2, 3 in it. So using those sets, question A wants us to find A complement. So I do see that apostrophe. And remember, putting it together using our guide on the side here, remember, whenever you see that apostrophe, it means what's actually not in that set, but still in the universal set. So because the apostrophe is attached to A, really this means what's not in set A, but still in the universal set. I'll just put a capital cursive U for universal set. And when you do this set operation, this is our first set operation. There are 3 in this video. The first is complement. So whenever you do a set operation, your answer is another set. So we do still need to keep drawing those curvy brackets. So I drew my first curvy bracket. So it's not an A. Well, if I look above, A has 1, 3, 5, and 7 in it. So we want what's not an A, or in other words, the opposite of set A, but still in the universal set. So if I get rid of 1, 3, 5, and 7 from the universal set, what's not in A, but what's left over in the universal set would be 2, 4, and 6. So those are all of the numbers that were not in A, but we're still in the universal set. You always, always look at the universal set whenever you see that apostrophe, that complement symbol. And it doesn't hurt either to check your answer to make sure you didn't forget any of them. So if A was the set with 1, 3, 5, 7, the opposite of A would be 2, 4, 6. So you should never ever have an element that is both in A and its complement, because complement means opposite of. So they should have all the opposite elements in its complement. So the set with 2, 4, 6 would be the final answer. Let's try another one. If we look at B wants B complement, because I see that little apostrophe attached to B. So putting it together, this actually means what's not in set B, or the opposite of set B, but still in the universal set, of course. But still in that universal U set. So B complement, well, if I look at B now, B has 1, 2, 3 in it. So I'm comparing to the universal set. If I get rid of 1, 2, 3, all the leftover elements in the universal set that were not in B are 4, 5, 6, and 7. So if set B was 1, 2, 3, its complement is 4, 5, 6, and 7 as the final answer. The next set operation is called intersection. The intersection of sets A and B, which is written with an upside down U shape, or like a horseshoe shape opening down. So whenever you see that U shape opening down in between two capital set letters, that is now going to signify intersection. We have a lot of U's in this section. We have the universal U, we got the intersection U, and then we're going to see on the next slide we have what's called a union U. But whenever that U is opening down, that is intersection U. And that intersection is the set of elements that are common to both sets, A and set B. This definition can be expressed in set builder notation as follows. So in their notation, they have the set of X such that X is an element of A and X is an element of B. So the keywords were what's common to both sets. Now in the definition, they use sets A and B, but it doesn't always have to be those particular letters. So the idea is what's common to both sets. So when I see that U shape opening down, when I see the intersection symbol, my memory trick is, I think, matches. Where do these two sets match at? That's the intersection. Looking at some examples, example 3 wants us to find each of the following intersections. They have U equals. Remember, when it's U equals, that means the universal set. So the universal set, or all the possible answers by the end of the question, are the numbers 1 through 7. So the universal set equals the set of 1 through 7. Subset A is the set with 1, 3, 5, 7. Subset B is the set with 1, 2, 3. And subset C is the set with 2, 3, 4, 5, 6. So they give us a bunch of subsets of the universal set to work with. So we're going to use these sets for parts A, B, and C. So A says A intersected with B. So if I bring these sets down, A was 1, 3, 5, and 7. And I want to intersect it with set B, which was the set with 1, 2, and 3. And you don't have to show all this work. I'm just trying to write everything out so I can explain it better. But if you want to go right to the final answer when you're working on your My Math Lab assignments, that's fine. But again, as soon as I see that intersection symbol, my memory trick is matches. So where do these two sets match? Well, they both have a 1 and a 3 in common. And whenever we use a set operation like intersection, our answer is going to be another set. So we're still going to have those curvy brackets. But we do have the set with 1, 3 as the final answer. I'm going to erase it so I can move this answer up so that I have more room to write with the other parts here. But we got a final answer of the set with 1 and 3. Looking at part B now, B wants us to do A intersected with empty set. So A again was 1, 3, 5, and 7. And I'm going to intersect that set A with the empty set, which is no solution. It has no elements in it whatsoever. So again, I see the intersection symbol. I immediately think matches. So where do these two sets match? Well, they have nothing in common. They have no matches. So the answer is going to be no solution because there are no matches. So I get empty set again as the final answer. Keep in mind the homework might have the empty set written this way, or the other way was set brackets that have nothing but air in them. They were literally empty. So either way, we still get empty set as the final answer whenever you intersect empty set with any other set in the world. And then finally, looking at part C. C says A intersected with the U meaning the universal set. So A again is still 1, 3, 5, and 7. And we're going to intersect it with universal U, which was the numbers 1 through 7. And it looks like I'm running out of room, so I'm going to move my answer to part B up to create some more room here. So we said B was the empty set again. There we go. And now, as I look at A and the universal set, where do they match? Well, they match at 1, 3, 5, and 7. So that's going to be the final answer. Now, you could leave your answer like this, or if it's a multiple choice question in the My Math Lab homework, you might not see this listed as a potential answer. Because what happened is we got one of the original sets back again. We got set A back again. So they most likely would just abbreviate it as set A. So you could say, well, we got the set with 1, 3, 5, 7 back again as the final answer, or you could just simply select capital A for set A. We got set A back again when we intersected it with the universal set because those were all the matches. So set A, final answer to part C. The third set operation we're going to work with is union in this course. So we've dealt with complement, intersection, and now union. So the union of sets A and B, which is written by, surprise, surprise, another U. So this U is opening up. You might be saying, well, how do I know if it's a union U versus a universal U? Well, you'll just have to look at the context of the question. If that U that's opening up is in between two set letters, two capital letters, then they're referring to union U. Whereas if the U is by itself, or if it's like U equals, that's the universal U, meaning all the possible answers you could have by the end of the question. So we have two different U's here. So back to union U. So the union of sets A and B, which is written A union B, or we could even say A united with B, is the set of elements that are members of set A or set B or both sets. So here's their fancy set builder notation, where X is an element of A, keyword here is or X is an element of B. So what does that really mean? Well, it means we don't care about matches anymore like we did with intersection. My keyword when I see that union U is just to simply combine the sets together or list them all out. Who cares if the sets match? Just list all the elements you see out. So you're going to combine the sets because of the word or, meaning we're happy with all the answers in one set or the other set or both. Just merge them all together, combine them all together. And that's all you do with union. So trying it, looking at example 4, the universal set is going to be the numbers 1 through 7 again. Set A is 1, 3, 5, 7 again. Set B is 1, 2, 3. Set C is the set with 2, 3, 4, 5, 6. And we're going to find each of the following sets. So starting with A, it says A union B, or A united with B. So if I bring down the sets to see it better, set A was 1, 3, 5, and 7. And I'm going to do a union U. I'm going to unite it with set B, which was 1, 2, 3. And we just look up our memory trick. It might help to jot these memory tricks for the set operations in your notes somewhere so you can easily see it when you're doing your homework. But as soon as I see that that's a union U, I think combine the sets together. So yes, they do have a 1 in common, but who cares? So you just merge the sets together so there's a 1, a 2. I'm checking off the elements as I go to make sure I don't miss any. There's a 3, there's a 5, and there's a 7 when I combine the sets together. If they match, you only list the element once. I don't repeat any of the elements. So here's the final answer. When I merge those sets together, I get 1, 2, 3, 5, 7. That set as my final answer. Again, it's a set operation, so I do need those curvy set brackets around the final answer, and all of these are going to be in roster method unless they specify otherwise in the homework. So I just put those commas in between all the elements. So you just combine the elements together and you are done. Let's look at B. So B says B union C, or B united with C. So B was 1, 2, 3. And now we're going to unite it or do a union with C, which was 2, 3, 4, 5, 6. And as soon as I see that union U in the middle of those curvy set brackets, I immediately think combine the sets together. So we do tend to get longer answers when we do a union. So when I combine the sets together, I have a 1 over here, I have a 2, we have a 3. Again, we have some matches, but who cares? We don't care about matches with the union. We have a 4, check, we have a 5, and we have a 6. So between the two sets, when I put them together, we have 1, 2, 3, 4, 5, 6 in set brackets as the final answer. So combine the sets or list them all out are usually the memory tricks I hear with union U. I actually have one more example. I couldn't quite squeeze it onto this slide. So let me try to erase so that I can try to find room somewhere for it. Here we go. So I'm just going to put it somewhere on the right side of this slide. So the other example that I have here was part C, and it was set C united with the empty set. So set C was 2 through 6. And we're going to union or unite it with empty set. Now don't overthink it. They'll try to be tricky like this in the homework where they put in the empty set. So remember, union U, as soon as you see it, think combine the sets together. The problem is that empty set has no elements in it whatsoever, so empty set contributes nothing when it's a union U. So when I combine the sets together, I still get back 2, 3, 4, 5, and 6. And empty set, I might as well ignore it with union U, which was totally different than when I intersected with empty set. Then it dominated the answer, but with a union, empty set, you can ignore it. When you combine the sets together, you get back the other set, which happened to be set C. So we get back set C, or 2, 3, 4, 5, 6 back again for the final answer to this extra part C that I just threw on this slide here. So how can they make these set operations a little bit trickier? Well, they're going to mix a bunch of operations all together within the same question. So it's important that we keep in mind what each of the 3 set operations means to do, our memory tricks, but also we have to be aware of order of operations. Yes, there's an order of operations even when we're talking about sets in math. Now you might remember from algebra, there was an order of operations, or PEMDAS. Please excuse my dear Aunt Sally, however you might have learned it. And the order of operations are kind of similar for sets, is the good news. So the P in PEMDAS stood for parentheses, and it's the same with sets. Really, with any type of math you're studying, you're always going to do inside parentheses first. So the P still stands for parentheses. And when we say parentheses, we really mean any sort of grouping symbol. It could be normal parentheses, the open parentheses, it could be solid brackets, it could be the squiggly set brackets. But if you see any sort of grouping symbol in the original question, we're going to do inside parentheses from left to right to begin. And if you see parentheses inside parentheses, we will do the innermost parentheses first. We'll work our way from the inside out. I could see my math lab trying to pull something like that, is why I mention it. So inside parentheses first. After we take care of everything in parentheses, then we're going to do the complement next. That was the apostrophe symbol. So we're going to do the apostrophe symbol from left to right next. After we take care of all the complements, then everything else will be last. So any kind of union symbols or intersection symbols we haven't done yet, we'll take care of those from left to right. We always go as we're doing these order of operations. So example 5, given that U equals, so that's the universal set, when it says U equals, the universal set is the set with little a, b, c, d, e in it. Set A has little b, c in it, and set B has little b, c, e in it. We want to find each of the following sets. So part A, in parentheses, they have A union B. Remember, the U in between 2 capital letters, when it's opening up like that, is a union U. So they have A union B, or A united with B. And then outside the parentheses, I know it's kind of hard to see on the slide here. It'll be easier to see in my math lab. But there is an apostrophe, or a complement, floating outside those parentheses. So we're going to use the order of operations. So step 1, we said if you see parentheses, you always do inside parentheses first. Well, inside these parentheses is A united with B. So we got to calculate that first. So A was little b, little c. And I'm going to unite it with set B, which is little BCE. Think back to our memory trick for union. Union means just simply combine the 2 sets together. And between the 2 sets, we have a little B, we have a little C, and we have a little E. We don't care about matches with union, just simply merge the sets together. So we just figured out the answer to what's inside parentheses is BCE. Now step 2, Now that we've finished up the parentheses, we look for complement. That's the apostrophe symbol. And there is a complement outside the parentheses, which means you're going to apply the complement to the answer from step 1. You're applying the complement to A union B. Well, we said A union B, if I bring it down, was B, C, E. So when I apply the complement to that set, to that A united with B set, think about what that apostrophe, that complement means. It means, this was the tricky one, what's actually not in that set, or the opposite of that set. It means what's not in that set, but still in the universal set. So what's not in that set, but still in the universal set. Or the opposite of that set. So if I go back to the universal set, that was the set with all the possible answers, that's the U equals set, I'm circling it. If we don't want the set with B, C, E, let's get rid of it. B, C, E. So what's still in the universal set after I get rid of little b, little c, little e is A and D. So the opposite of B, C, E would be the letters A, D. And we put set brackets around it. Whenever we do any operation, we still have those curvy set brackets. And as I go back to the original question, we've taken care of the parentheses in step 1. We just took care of that apostrophe, the complement in step 2. There's nothing left to do, so that must be the final answer. So the only thing you would type into the answer box in my math lab is what we've done last, at the end of the last step. So the final answer is the set with little a, little d in it. I'm going to go ahead and move this answer up, and then we can work on part B. So you might want to pause it, pause the video if you're still writing. So I'm going to erase. And we said the final answer was elements A, D inside those set brackets. Using the same sets, let's take a look at question B. It says A complement, because it's A apostrophe, intersected with B complement. All right, well, we see lots of set operations there. Step 1, you would do parentheses first, but there aren't any. So now I go to step 2. It says we do complements from left to right. The apostrophes from left to right. Well, we got a couple complements here. So as I go from left to right, the first complement that we see is A complement. And remembering what complement means, as we just mentioned a few minutes ago, complement actually means what's not in that set that the apostrophe is attached to. So when I put it all together, it means what's actually not in set A, but still in the universal set. It's always compared to the universal set. So it's not in set A, but still in the universal set. So when I go up here, I see that set A has little b and little c in it. So if I get rid of little b and little c, what's not in that set, or the opposite of that set, is going to be A, D, and E. A, little d, and little e. So the opposite of A, or what's not in A, you can think of that complement as meaning, is A, D, E. And it doesn't hurt to check just to make sure it makes sense, because complement is the easiest operation, I think, to miss. So set A was B and C, what's the opposite of that set? Would be A, D, E, all the other letters in the universal set. Good. All right, so we took care of A complement, done. We are still on the complement step 2 of the order of operations, because we have another complement to now take care of. So the next complement, as we go from left to right, is B complement, or B apostrophe. And we said complement means what's not in that set. So in this case, not in set B, but still in the universal set. So as I go back up to the original question, because we're still using all the same sets from example 5 here, set B has little B, C, and E in it. So when I go back over to the universal set, when I get rid of little B, C, and E, the other letters are A and D. And let's go ahead and erase all these extra markings so we can see this better, just to check our answer. So if set B was B, C, E, what's not in that set, the opposite, would be letters A and D. Good. So that looks good. All right, so now we go back. After each step, we constantly go back to the original question to see what operations are left. So we did A complement, we did B complement. Now we're on step 3, everything else. The only thing left is an intersection symbol in the middle there of those complements. We're going to intersect our answers from steps 1 and 2. So we're intersecting A complement with B complement. And our memory trick for intersection was matches, or what do these two sets have in common? Well, they both have an A and they both have a D in common. And we have those set brackets around our answer still. So it's the set with little A, little D. We've taken care of all the operations from the original question, so this must be the final answer. So we get the same answer as we got for question part A, which is the set with A, D. So we saw a couple of examples of what to do when there are multiple set operations and we have to abide by the order of operations, and we keep in mind the memory tricks for each of the 3 operations. But that was when we were given the sets. What if we're not given the sets, but instead we're given a picture of a Venn diagram, like with example 6 here? So we can still use the same memory tricks, but the thought process is just a little bit different when we change to a visual perspective. So keep in mind the universal U will be always in the upper left-hand corner of these Venn diagrams. And the Roman numerals are labels. They're not elements, so we can ignore the Roman numerals. So all the possible answers are in the box with the exception of the Roman numerals. So we're going to use the Venn diagram to determine each of the following sets. So we're going to start off with the easier questions, and after every couple of examples, we're just going to get a little bit trickier as we go. So A says set A intersected with set B. You'll notice each of the sets is represented with a circle. It's labeled. So intersection, our memory trick was matches. Matches visually means where do the circles overlap. So the matches is the overlap spot. So where do circles A and B overlap? Well, they overlap right here. I know it's kind of hard to see, but there is a 5, a number 5. And we still, unfortunately, need those annoying set brackets around our answer because we're doing a set operation. So we get the set with 5 is what they have in common. Those sets, those circles have in common. So the set with 5 is the final answer to A. So now taking a look at B. B says A intersected with B is in parentheses now, and we do have an apostrophe, a complement to apply to what's inside the parentheses. So whenever the apostrophe is outside parentheses, it's floating outside parentheses like this, it really means to apply it to the set operation that's inside the parentheses. So let's think it all out. We just said a minute ago that the intersection means the overlap. The overlap, what's in the middle of those circles. However, the apostrophe means what's not in that set that it's attached to, but still in the universal set. So what's not in the intersection, what's not in the overlap, is really what this means when we put it all together. So if we don't want what's in the overlap, we don't want the 5, we want everything else that's still in the universal box. So that's going to be the set. We got 2 and 3 that's outside of the overlap. We also got 7, 11, and 13. And don't forget about we got 17 and 19 as well. Again, ignore the Roman numerals. They're not elements, so they're not going to be part of the final answer here. So we get a really long answer. We get the set with 2, 3, 7, 11, 13, 17, and 19 is everything outside of the intersection. Let's take a look at part C now. And I'll change pen colors. So C says A union B. We got the union U. The U opening up in between two set letters, two capital letters is how I know it's union U. And our memory trick for union was to combine the two sets together. It still means that. So just simply combine these two circles together and list all the elements in the circles. So we have a 2, 3. We have a 5. And we have 7, 11, and 13. After we combine the circles together, and that's going to be our final answer. Okay, now we're going to look at D. So question D, we have A union B again, but now it's inside parentheses. And we have the complement, the apostrophe, outside the parentheses. So I'm really going to apply it to the union. So if union was everything inside the circles combined, and complement means what's not, so putting it together, what's not inside the circles, in other words, it means everything outside circles A and B. Outside the circles. So again, A union B, we combined the circles together, which was everything inside the circles. So if I want to do a complement, an apostrophe to that union, the apostrophe means the opposite, or what's not inside the circles, so that means what's outside the circles. So what's outside the circles is 17 and 19. So is it hard? No. But you can probably guess how they're going to try to trip you up a little bit in the My Math Lab homework is they're going to constantly go back and forth between intersection and union. So you just got to pay extra close attention to, is the U shape opening down for intersection, for matches, or is the U shape opening up for union, for combining the circles together? And then it's probably hard to see because it's on the bottom of the slide, so I'm going to write it up higher. But I do have another question part here. And this is part E. And the question part I'm going to move up is, this is the hardest one here. It's A complement union B. A complement union B. So what I would recommend for this type of a question, for when they give you the diagram and they have all these set operations, and the complement is attached to an actual letter rather than floating outside parentheses, is I would chop this up into 2 steps. So what I'm going to do, because it's kind of tricky to see it all out. You're welcome to, if you're a visual person, maybe you prefer to do the whole thing in your head, that's fine. But I'm going to choose to break this one up into 2 steps. So first, I'm going to do the complement, because remember, you do a complement after parentheses. There aren't any parentheses here, so I'm going to do the complement. A complement means what's not in set A, but still in the universal set. So everything outside of circle A would be 7, 11, 13, 17, and 19. So here's a complement. In fact, let me try to write this a little bit smaller so I have more room to work. So if I look at a complement to begin, we said that means was outside of circle A. 7, 11, 13, and don't forget about the 17 and 19. So that's just a complement. Now, we're going to unite with B. So I'm going to bring down the union U. B is just a normal B. There's no apostrophe there. So we just simply list everything inside circle B. So inside circle B, we have 5, 7, 11, and 13. And now, so that was step 1, is I did a complement first, and I brought down set B. Now step 2, I'm going to do kind of like the last slide. Union U means to combine these 2 sets together. So between the 2 sets, we have a 5. Check as I go. We got a 7. We have an 11. We have a 13. We have a 17. And we have a 19. So that's the final answer if you break it up into 2 steps. A complement united with B, when you combine those 2 sets together, you get a whole bunch of elements. You get 5, 7, 11, 13, 17, and 19. If you wanted to do it all visually as one step, it's definitely possible. It's just a little bit trickier. You might want to kind of color code it. So to get the same answer visually, if I highlight in red a complement, that was everything outside of circle A. So all of these elements over here is a complement. And then we're going to combine it with set B. So I'm going to do set B in aqua. So that's everything in circle B. And this aqua highlighter here. And union means to combine the 2 colors together if you're color coding it. So when I combine all the elements with either color, either the blue or the red or both, either the aqua or the red, I should say, or both, we see that we do have a 5, which was part of the final answer. We have 7, 11, 13, and we have 17, 19. So if you wanted to color code it, just think union, you're going to combine the 2 sets, so any element in either color is part of the final answer. If this had been an intersection symbol instead, then you would only list the area that has both colors on it, because intersection would mean the overlap or the matches, what they have in common instead. But that is, either way you do it, that's the final answer for part E. There are probably going to be a couple of word problems near the end of the section 2.3 homework. And if you click on the question help button, view an example, this formula is going to show up. I promise it's way easier than it looks. So let's translate this formula, but pretty much it's a formula to calculate the number in the union. So that little n means number of. Little n always means number of something, in no matter what math you're studying. So number of, the cardinality. So if you want the number in the union of two sets, is what this formula is designed to give us. It equals, first you're going to count up the number in set A, then you are going to add it to the number in the other set, set B, and then after you add it, you're going to subtract the number in their intersection, the number in their overlap. Why are we subtracting? Because after you add the two sets, what happens is you double count all the elements that are in the overlap, and so by subtracting the overlap, we subtract away the extra count to get the right answer. Now the way I think of this fancy formula here is union in word problems means or. It means the same as or. So the or number equals the number in set A, I just put an A for that, plus the number in set B, minus intersection is the and number in word problems in math. So to find the or number, the union, you're going to take the number in one set plus the number in the other set minus their and number, minus their overlap number. So seeing this formula in action, example 7 says, according to factmonster.com, among the U.S. presidents in the White House, as of 2018 anyway, 26 had dogs, 11 had cats, and 9 had both dogs and cats. How many U.S. presidents had dogs or cats in the White House? Please keep in mind, or in this course is going to always be the inclusive or, meaning one or the other or both. So in other words, how many U.S. presidents had just dogs, had just cats, or had both dogs and cats? That's what we mean by inclusive or, one or the other or both. So as soon as you see them asking you for the or number, you see 3 numbers given to you. These are all clues that we can use our new formula, where the or number equals the number in one set plus the number in the other set minus their overlap, the and number. So we're solving for the or number. So I'm going to bring that variable down. The number in one set, well, it says 26 had dogs, and then we hit the comma. As we go back through, we're going to use each of those numbers. So 26 belongs to one set, the dog owner set. So it's your choice. You can plug in the 26 into either A or B. It honestly does not matter. So I'm just going to go in alphabetical order and we'll say A. So A represents all the dog owners, so I'm plugging in 26 into A. Done. So I'll slash through that. Now, 11 had cats. 11 people had cats. So 11 also belongs to one set. So again, you could plug it into A or B. Since we already plugged into A, I'm going to plug it into B. In other words, set B represents all the cat owners. So B is now 11, and don't forget to bring down the plus symbol in between those sets. The only number left is 9 had both dogs and cats. It's literally part of the phrase with the word and is why I call it the and number. So 9 is the overlap, 9 is the and number, plug it in, and bring down your minus sign. It's part of the formula. So here we go, now we just compute out. So we're going to do 26 plus 11 first, which gives us 37. Bring down the minus 9. Now we're going to do our 37 minus our 9. And we get a final answer of 28. But when you're looking through these word problems, when it's asking you for whatever scenario, when you see the word or in that question at the end, you're going to be able to use this formula. You'll add together the two sets, and you'll minus the number in the overlap every time, and that will give you the final answer. So 28 U.S. presidents had dogs, had cats, or had both of those animals.